All right, chapter P, we're still in our prerequisite chapter. 5b is multiplying and dividing rational expressions. I think these are so fun. I know, I'm a weirdo, but I think these are fun. What's the grown-up way to say fraction? Rationals, all right? The way that we're going to do this is you're going to factor each part of the fraction. Factor the numerator, factor the denominator. If you are multiplying the two fractions together, you can cancel out any numerator with any denominator. So it can be top and bottom, or it can be like cross-canceling. And remember, if we're dividing, we have to stay, change, flip. Or some of you guys say keep, change, flip. Have to do that first, and then you can start canceling out a bunch of things. So let's just look at some examples here. First of all, do you see these two fractions? These two rationals. What are we doing here? Are we multiplying or dividing? We're multiplying. Remember, you can't just cross out x's whenever you feel like it, because what are those bound by? Plus and minus signs, right? So this is really x minus 2, x plus 3, x squared minus 9, and x plus 4. So I like to look at everything in pieces. Top left, is there anything I can factor out of x minus 2? No, so I'm just going to rewrite x minus 2. Top right, is there anything I can factor out of x squared minus 9? What does that become? X plus 3 and x minus 3. Bottom right, x plus 4. Anything I can factor out? No, so it's just x plus 4. And then bottom left, anything I can factor out? All right, I'm going to do this one way, one time like this, and then I'm not going to do this again. But when we are multiplying fractions, you just multiply the numerator together, correct? So this is really x minus 2 times x plus 3 times x minus 3 over x plus 3, x plus 4. Does everybody agree with me? Now, I'm going to do this one way just to show you guys. What is exactly the same on the top and the bottom? The x plus 3, so those cancel out. So what are you left with? On the top, you have x minus 2, x plus 3. What did I? I did. Thank you. So what are you left with on top? X minus 2, x minus 3 over x plus 4. It's your final answer. Now, what I wanted to show you guys, you don't have to rewrite this step. You can cross-cancel here if it's the same on top, same on the bottom, anywhere. Even though there's a multiplication sign here, you can still go like this and like this. You don't have to combine them all together. If you want to, that's fine, but you don't have to. Right? Again, same thing. Top left, what can we factor? Okay, x squared minus 9, what does that become? X plus 3, x minus 3. On the bottom, can I factor anything out? Bottom left. Can I factor anything out of x plus 3, guys? No, okay. So times, can I factor anything out of x plus 4? No. Can I factor anything out of x minus 3? No. Anything that is exactly the same on top and bottom, you can cancel. So do you guys see how I have an x plus 3 here and an x plus 3 here? Yeah? I have an x minus 3 here and an x minus 3 here. Yeah? So what are you left with? X plus 4. That's it. All right. No more on this page. Here we go. See, this is what I was talking about. This is a big mess. Just take everything one step at a time. Look at your top left fraction. Numerator over here. A times C. Again, many of you do this a different way. That's totally fine. Do whatever you need to do. I'm going to focus on my top left numerator. What are the factors of negative 12 that multiply to give me negative 12 but add to give me a 1? Okay, so x plus 4, x minus 3. Now my a term is not 1, so I'm going to divide both of those by 2. You guys with me? Okay, so I am left with what? X plus 2 and 2x minus 3. Okay, so I'm going to put that, again, top left. X minus 2 and 2x minus 3. Now I'm going to work on my top right. You can work anywhere you want. You don't have to do the same thing I am. But if I look at the top right, what can I take out of x cubed, x squared, and x? All right, I'm going to take out an x, and that leaves me with x squared minus 3x plus 2. Can I factor that a little more? Are there factors of positive 2 that multiply to give me positive 2 but add to give me a negative 3? Yep, what are they? Minus 2 and minus 1. Okay, so then my top right is x times x minus 2 minus 1. Everybody with me? Okay, so now I'm going to focus here in green, my bottom left. Are there factors of negative 5 that I can multiply to give me a negative 5 but add to give me a positive 4? Multiply to give me a negative 5 but add to give me a positive 4. So x plus 5, x minus 1. Yeah? Okay. Pick another color. Now I'm going to focus on the bottom right. Can I take anything out? Okay, take out a 2x. What are you left with? If we factor out a 2x, what are we left with? 2x minus 3. Okay, so that's my bottom right. 2x and then 2x minus 3. Now, any way you guys want to do that is up to you. I personally like to just look top left and then top right. Bottom left, bottom right. But you can do whatever you want. Just make sure all 4 pieces are factored. Now, anything that is exactly the same on top and bottom, you can cancel. What in the numerator can I cancel? 2x minus 3 and 2x minus 3. Good. What else? Good. X minus 1 and x minus 1. Anything else? Oh, I like that you said that, Hannah. Can I cancel out these x minus 2's? Why not? They're both where? In the numerator. They're both in the same spot. But is there something else I can cancel? Is there something else still hanging out? The x, right? I can cancel this x with this x. So with this big old mess, what am I left with? This should be a plus, guys. What am I left with? Say it again, Angel. Okay, in the numerator I have x plus 2, x minus 2, and on the bottom I have what? 2 times x plus 5. Now some of you are going to say you want to either FOIL the 2 together. Hang on. You want to FOIL the 2 together, or you want to multiply the 2 into the x plus 5. Don't do that. We're factoring, so that means we're making smaller. We're pulling apart. And then we're simplifying. Hannah, question.
Why it wasn't x when you took out 1x, but then I realized it wasn't x in the second power. It was 2.
There you go. Okay, you answered your own question. All right, again, multiplying or dividing. We're multiplying. So now let's factor first. I know some of you are saying, oh, I already have the x minus 1. I already have the 5s and the 25. That's fine, but let's focus on each piece. Get in the habit of doing the same thing. Top left, can you factor anything out of 5? No. Top right, can you do anything with x minus 1? No, we're just going to put it in parentheses. Bottom left, can you do anything with x minus 1? No. Bottom right, can you factor anything out? No. Once you've gone through the steps and said, okay, everything is factored, now you can start canceling out. What cancels where? X minus 1 cancels here, correct. What else? God bless. The 25 and the 5, okay? What does this look like? What's left in my numerator? I've crossed everything out. There is a 1. Don't forget that. So when you have this simplified, it's 1 over 5 times x minus 2. Does not become 0, guys. Be careful with that. It's a common mistake. All right, same thing, same thing. Let's focus on top left. What can I do in the top left? X squared minus x minus 6. What are the factors of negative 6 that multiply to give me a negative 6, but add to give me a negative 1? Good job. X minus 3 and x plus 2, okay? You want to go, okay, I already got that one taken care of. Go ahead and do that. Cross it off your list. Is there anything you can do with x plus 3 in the top right? Nope, so I'm just going to rewrite x plus 3. Bottom left. What can I factor? What does that become? X squared plus 6x plus 9. X plus 3, x plus 3. Good. X plus 3, x plus 3. What are the factors of positive 9 that multiply to give you 9 but add to give you 6. Good. And then what happens with x squared minus 4? Perfect. X minus 2, x plus 2. Perfect. Now that we have every piece factored, let's just cancel. Take your time. Do I have an x minus 3 on the top and the bottom? No. Do I have an x plus 2 on the top and the bottom? Yes. So go ahead and cancel it. Do I have an x plus 3 on the top and the bottom? Yes. So what are we left with? What's my simplified answer? X minus 3 in the numerator, x minus 3 over x plus 3 and x minus 2. Perfect. Good job, you. Now notice, guys, when you cross out, it's 1 to 1. Do you guys see here how we had an x plus 3 and an x plus 3, correct? You cannot cancel out both of these x plus 3s with just one up here. It has to be a 1 to 1 ratio. Same thing on the top, same thing on the bottom. If there's 2 on the top and 2 on the bottom, then cancel them both. But if that's not the case, you cannot just cancel just because you see one of them. Now, how is 6 a little bit different? There is division. If you guys miss that, if you forget to keep change flip, then your whole problem is wrong. So it's really important that you guys pay attention. The first thing you need to do, the absolute first thing before you factor anything, is to keep change flip. You keep your first fraction the same, your first rational the same. X cubed over 8 and x squared minus 4. What do we change our division sign to? Multiplication, and then we flip. So the denominator becomes the numerator, and the numerator becomes the denominator. If you guys don't do that, your whole problem is wrong. So you've got to make sure you do that. Now, once you do that, now we can go ahead and start factoring and canceling everything out. Does anyone notice anything about my two numerators? They are cubes. Good. Is this the difference and the sum of perfect cubes? Yes or no? Yes. X cubed is a perfect cube, and so is negative 8. And so x cubed is a perfect cube, so is positive 8. So do we remember the pattern for cubes? Oh, it's a minus b. Okay, so this is going to be x minus, what's the cube root of 8? 2. Good. And then what is this going to become? X squared plus 2x plus what? Oh, good, which is 4. Good, very good. Does everyone agree? Okay, so what's going to happen over here? What does the top right become? It's not the same. What is it? Come on, tell me. X plus 2. And then what happens inside? X squared minus 2x, right? Plus 4. Okay. Bottom left. Bottom left, what does that factor to? X plus 2, x minus 2. Good. And then what happens? Can I factor that? Do I need to even try to factor it? It is, but what do you guys notice? Do you notice anything? There's 2 plus signs, okay. What else do we notice about the entire problem? It is, you're right, Hannah, but anybody notice anything? Top left and bottom right are the exact same, right? If you guys notice it, make your life a little easier. Go ahead. You can say, oh, wait a second. This trinomial is the same as this trinomial. If you didn't notice that, no big deal. But I'm just saying, try to see patterns. Try to see things. Make your life a little easier. Do you notice anything else you can cross out? I have an x minus 2 in the numerator and an x minus 2 in the denominator. What else? X plus 2 in the numerator, x plus 2 in the denominator. So what are you guys left with? X squared minus 2x plus 4. Does that factor at all? Are there factors of 4 that multiply to give you 4 but add to give you a negative 2? No. Okay, so you're good. I will say, though, just be confident in yourself. If you guys have to have a plan, kind of have to have a plan of attack. You have to look at things and say, okay, I'm going to do the same thing every time. Because if not, you could get lost in your work. That happens very easily. So just be careful. All right. What do you notice here about number 7? It's what? It's a cubed. It is. But what is the operation that's being performed? Division. So what should we do first? We should keep, change, flip. So I'm going to rewrite this as x cubed minus 1 over x squared minus 1, right? Check me, make sure I don't rewrite it incorrectly. X squared plus 2x plus 1 over x squared plus x plus 1. Everybody with me? Okay. What do you notice about top left? Perfect cube. Okay, so let's... Wait, hang on one second. Say it again.
Can't you cancel out, like, with the x squared at the bottom and the negative ones and cancel them?
No, I'm very glad you said that, but we cannot just cancel here and cancel here because these are attached to each other with your plus or minus sign. So you have to fully factor first and then you can cancel. If you have a plus or minus sign attached, you cannot just willy-nilly cross stuff out. So in my top left-hand corner, is that a perfect cube? Yes. So what is this going to become? What is it? I have x minus 1. And then what do I have? X squared plus 1x plus 1. Excuse me. Okay. Top right, can I factor that? Factors of 1 that multiply to give me 1 but add to give me 2. So x plus 1, x plus 1. You guys agree? Okay. Bottom left, what can I do? Difference of perfect squares, so x minus 1, x plus 1. And then can I do anything with x squared plus x plus 1? No. But what do you notice about the x squared plus x plus 1? What it cancels with what? In the numerator, right? Everybody see that? So as soon as you see that, cancel that out, cancel that out. Perfect. Anything else? I have an x plus 1 on the bottom with an x plus 1 on the top. Does it matter which one I cancel out? No. Anything else? X minus 1 and x minus 1. So all of that garbage, what am I left with? X plus 1. Yes. Why? I cancel. It was the exact same here as it was here. Now, guys, I'm telling you, some of you are a little messy and you're going to get lost in your work. If you need extra paper, if you need an extra room, you need to do that. Some of you are super neat and organized. That's not going to be a problem. But some of you like to just do as least amount of work as possible. And then you might get lost in what you're doing. So just try to be as neat and organized as possible. Let's look at number 8. What's the first thing I should do in number 8 since it's a division? Keep, change, flip. So you're going to keep x over x minus 1. I said the other day it might be good, might be helpful for you if you put your binomials or trinomials in parentheses so you see, okay, this is what has to be the same. I just can't cross off x's. I'm going to change my division sign to multiplication. And then this becomes x squared minus 1 over x squared. Everybody with me? All right, so top left, can't factor anything. Top right, what can we factor that into? X squared minus 1, what does that become? X plus 1, good, and x minus 1, good. So that's gone. Can I factor anything else? So what, x and x? Oh, you could do that if you wanted to. Write out 2 different x's. Or you could just leave it as x squared. Now, do you notice anything on the top and the bottom that is exactly the same, guys? The x minus 1's good. What else? I have 1x on the top, and I can cancel out 1x on the bottom, and I'm left with just 1x. So rewrite your answer. What is your numerator? X plus 1. And what is your denominator? Over x. Good. Good, good, good. One more. And then you can get your new IDs. Aren't these fun? They're not horrible. Come on. All right. I see a division. I have a big fraction division problem. So I keep, change, and flip. So I'm going to rewrite x squared minus 14x plus 49. Some of you are going to say, can I just go ahead and factor that? If you want to go ahead and factor, that's fine. I just like to rewrite and then work on my factoring. So x squared minus 49 is on the bottom. I'm going to change my division to multiplication. And then we're going to flip. X plus 7 comes on top. And 3x minus 21 on the bottom. Hopefully, as you guys were rewriting this or looking at this, you're starting to see, oh, I see a bunch of things. It's already going to be able to cancel out. Look at your top left. That's a perfect square trinomial, correct? If you don't recognize that pattern, that is okay. You can still do A times C. What are the factors of 49 that multiply to give you a positive 49 but add to give you negative 14? It's going to be x minus 7 and x minus 7. If you notice the perfect square trinomial, it makes your life a little easier, but you can still solve the problem. Top right, can you factor anything out of x plus 7? No. Bottom right, can you factor anything of 3x minus 21? What? Okay, take out the 3 and you're left with x minus 7. Bottom left, what can we factor that into? Perfect. X plus 7 and x minus 7. We got a whole bunch of x plus and minus 7s, don't we? Take your time. 1-to-1 canceling out. So I have an x minus 7 in the numerator, and I'm going to cross it out with this x minus 7 in the denominator. Everybody with me?
What was that, an x minus 7?
Yeah. All right, what else can I cancel? I have another x minus 7 with another x minus 7. You guys with me? Yeah. All right. I have an x plus 7 and an x plus 7. What in the world just happened here? Everything canceled in my numerator. Good. And then what am I left with in my denominator?
3.
Just a 3. This is what I think is so neat. This whole problem, just cancel that. Everything's simplified to 1/3. You guys okay? All right, that's it. You guys might have a problem that on the onset looks like very cumbersome and a lot, and then when you factor everything out and keep change flip and all that, everything cancels out and it becomes 1. Don't freak out about that. No, I'm not going to say never, but very rarely are you going to have a problem like this, and you keep change flip, you factor, and nothing cancels. Very rarely does that happen. So if you come across a problem, especially on your WebAssign or something, and you're like, oh, nothing cancels, just check your work because you probably did something wrong. God bless you.